I'll try to explain this example in a simple way. First, let us go through the question. This example illustrates the simulation procedure when there is more than one system channel. Consider a computer technical support center where personnel take calls and provide service. The time between calls ranges from 1 to 4 minutes with distribution as shown in the table. There are two technical support people, Abel and Baker. Abel is more experienced and can provide service faster than Baker. The distributions of their service times are shown in the table. We can extract these informations from the problem. The first table is for time between arrival and its probability. The second table is service time and corresponding probability with respect to Abel. And the third one is for Baker. Random digits for arrival are given as 26, 98, 90, 26, 42. Random digits for service time are given as 95, 21, 51, 92 and 38. In Abel-Baker problem, we have more than one channel of work or service. Abel being faster than Baker, Abel is preferred. A customer arrives at time K. If both Abel and Baker are free, then the service goes to Abel because he is more faster than Baker. If Abel is busy, then service goes to Baker. If both Abel and Baker are busy, then customer waits for one of them to be free. Now let's start filling the table. The time between arrivals are given as 1, 2, 3, 4 and the probabilities are given as 0.25, 0.40, 0.20, 0.15. Accumulating probability can be found just by adding these probabilities. So the first one is 0.25 plus 0.4 becomes 0.65, 0.85 and 1.00. So, by looking at cumulative probability values, we can set a range for random digit assignment. 0 to 25, 26 to 65, 66 to 85, 86 to 0. Next, calculate the service time distribution and assign random numbers. The service time for Abel is given as 2, 3, 4, 5. Probability is given as 0.30, 0.28, 0.25, 0.17. Cumulative probability goes like this: 0.30 plus 0.28, 58, 0.25, 0.83, this plus this 1.00. Now by looking at the cumulative probability values, we can assign a range: 0 to 30, 31 to 58, 59 to 83, 84 to 0. Similarly, for the Baker table, the service time is given as 3, 4, 5, 6. Probabilities are given as 0.35, 0.25, 0.20, 0.20. Cumulative probabilities are 0.35 plus 25, 0.60 plus 0.20, 0.8. 1. Let's assign the range: 0 to 35, 36 to 60, 61 to 80, 81 to 0. Next, we need to find out the inter-arrival time. So for the 6 customers, the random digits for inter-arrival time are given as 26, 98, 90, 26, 42. We need to find the IAT value. For the first customer, it's null. For the second customer, the random digit is given as 26. Now we need to refer to the first table and see where 26 lies. 26 lies in this range, so we need to consider time between arrival value 2 and write it as the inter-arrival time. Next, 98. 98 lies here, so time between arrival value 4. 4. 90 also lies there, so 4. 26 and 42, they lie here, so 2 is the answer. The final table looks something like this. It has customer numbers, inter-arrival time. In Baker we have these three values: time service begin, service time, time service end. Similarly for Baker, time service begin, service time, time service end, caller delay, time in the system. We have found out the inter-arrival time in the previous table. Now let's find out 80. It is 4, 6 plus 4, 10 plus 2, 12 plus 2, 14. For this table, we need to consider the random digits for service time. The first one is 95. Now that both Able and Baker are free, the service goes to Able, where 95 lies. So in Able's table, time service begins at 0, service time is 5. So the time in the system is 5. Next customer arrives at 2. He sees that Able is busy, so he goes to Baker. The next value for service time is 21. We have to see the range where 21 lies here. 2. Service time is 3 as we just saw, and it ends at the 3 units of work is done, and the time in the system is 3. The next customer arrives at 6. Now both Able and Baker are free, so this customer goes to Able. The next random digit for service time is 51. So in Able's table, we have to see where 51 lies. Able's table, 51 lies, begins at 6. It is carried out for 3 units of service time. It ends at 9. So the time in system is 3. The next customer arrives at 10. Both are free, so he goes to Able. The next random digit to be considered is 92. We have to refer to the Able's table and find the range of 92. 92 lies here, so service time is 5. Service starts at 10, carried out for 5, ends at 15. Time spent in the system is 5 units. The next customer arrives at 12. He sees that Able is busy and Baker is free, so he goes to Baker. The next search for 89 and its range. In Baker's table, 89 lies here, so the service time is 6. Time service begins at 12, service time is 6, it ends at 18. Time in system is 6. The next customer arrives at 14, but he sees that both Able and B waits, and he sees that Able is going to finish the work early, so he chooses Able. So we need to consider the next random digit and seek the corresponding range. It is 3. Service can begin only once it has finished the previous job. So the time service, and we can see that there is a delay. So caller delay becomes 1. Coming back to the service time service ends at 18. 15 plus 3, 18. Now, time spent in the system includes the waiting time and the service time. So it becomes 3 plus 1, 4. This is the final table.